we are going to be learning about what we do when we are dividing with decimals. So in 5th grade, you have learned about what you do when there is a decimal in your dividend. We're going to add a decimal in our divisor now. So it's pretty easy, but I'm going to show you a little helpful step here that you can take that makes it pretty quick here. So first, let's think, what is easier? If I have these here, if I want to divide them into 8 or each of these into 8/10, what is easier? So is it easier for me to say 1, 2, 3, 4, 5, 6, 7, 8 and say I have 8 here, 1, 2, 3, 4, 5, 6, 7, oh, not enough. So I have 1 and 7 out of 8. Or is it easier to try and cut this into 10 pieces and then color 8, and then there's 2 out here, and I'd get the next 6 to make 8, and keep breaking them into groups of 8, like, right? What's easier? So I would say definitely just like finding 8 whole pieces is easier than finding 8 little pieces out of 10. So you're probably wondering, what is she talking about? So let's take a look here. So this problem here, 132 divided by 8/10. 8/10 and 8/10, they're the same problem. And so I can do this. Okay, but we can make it easier on ourselves. I would rather divide by 8 wholes than a decimal or a fraction. Like, right? Like, just like when we were dividing fractions, we used that multiplicative inverse and we flipped it to multiply because it was easier. We can turn this into a whole number and make our lives easier. Let's do that. So take a look at this problem here. How do you think we got from here to here? So take a look for a second. How are those problems similar? So in the divisor, this one has no decimal. So no decimal here. And this one has an added 0. Not sure if I spelled 0 right behind that purple there. Oh, I did. So we added a 0 here, and this has no decimal. These are actually the same problem. They're exactly the same. This is going to be a lot easier than dividing by these pieces, than taking 132 of these circles and seeing how many little tiny 8/10 goes into each of these. It's going to be a lot easier to say, here's 8, here's 8, here's 8, then here's 8 little pieces, here's 8 little pieces. It's going to be a lot easier to count by whole numbers than it is by part of a whole. So let's see how we got from here to here. So the first thing we're going to do is we're going to move the decimal in the divisor to the end of the problem. And you want to count how many places that was. So for this one, it takes 1 place to get it to the end. Now you're going to do the same thing in the divisor. So what you do to one part, you have to do to the other. It's kind of like when you're simplifying a fraction. You can't just change one number. You have to change a top and a bottom, right, to keep it the same. So when we change one, we have to change the other. So we made this 10 times bigger. So now we have to make this 10 times bigger. So if there's no decimal, that means it's at the end. So we move it over 1 place and we fill it in with a 0. So our new problem is 3790 divided by 4. So now we complete the division problem and the decimal goes straight up. Now when we divide, you should have something above each of these digits. So there are 4 digits in this problem. There should be something above each of them. So 4 cannot go into 3. So I'm going to cross that off. So nothing above the 3. 4 goes into 37, 4, 8, 12, 16, 20, 24, 28, 32, 36. So, oh, perfect. I have the right amount of fingers for this problem. 9 times. 9 times 4 is 36. So we're going to subtract. There's 1. Bring down the 9. 4 goes into 19. 4, 8, 12, 16. 20 is too big. So it goes in there 4 times. So, right, something came down, something goes up. So the 9 went down, so the 4 goes up. 4 times 4, 16. So 19 minus 16 is 3. And then the 0 comes down. 4 goes into 30. 4, 8, 12, 16, 20, 24, 28, 32 is too big. So it goes in there 7 times. 7 times 4 is 28. And there's 2 left over. So now one thing. When we're working with decimals, if it gives you the problem as a decimal, it wants the answer back as a decimal. It doesn't want a remainder. It does not want a fraction. It wants your answer either as a whole number that went in there perfect or back as a decimal. So what we can do is we can add another 0 and let's bring it down, right? This didn't change it. There's nothing there and we kept nothing there, but we're going to add another number at the end here. So 4 goes into 20 5 times exactly. 4 times 5 is 20. So it went in there perfectly a half time. So 947 and 5/10, or 947 and a half. So we move our decimal, match it. So we made this 10 times bigger. 10 times bigger. Complete your division, matching everything up. So let's try one more problem here. So this time we have to move our decimal 1, 2 places. And it's given us this decimal, so we're going to move it 1, 2. So we had to move it 10, 100. We're making this problem 100 times bigger. So we moved it 10, 100. So we're adding on this 0 here. So my decimal's here at the end. So I need something above the 6, the 7, the 7, the 4, the 0. Here's my decimal. I may need more at the end. If I do, we'll just keep on adding zeros. So 12 cannot go into 6. So really quick, I'm going to make myself a list of 12s. 12 more is 24. 12 more is 36. 12 more is 48. 12 more is 60. 72. 84. 96. And 108. So it should never get bigger than 9 times. Or you know you've got too big. But look, 2, 4, 6, 8, 0, 2, 4, 6, 8. It's just counting and then counting by 10s here, but it had to go up 1. So it goes in here 1, 2, 3, 4, 5 times. And here's 60. 7 left over, bringing down the 7. Goes in there 6 times. Is 72. So the nice thing about making this list is once I have my list, I don't really have to do much thinking. I just plug in my numbers. So 72 is 5 left over. Bring down my 4. So that goes in there 4 times. 4 times 12 is 48. So left over is 6. Bring down that 0. 12 goes into 60 exactly 5 times. So that is 60. So that one went in there perfect. So my decimal's just right there, boom, at the end. So as you are doing this, make sure you move your decimal, match it. Move your decimal, complete the division. So divide, multiply, subtract, bring down the next one. Every time something goes down, something has to go up, and then your decimal goes straight up. If you get to the end of the problem and there's still more, we're not just going to stick a remainder on there. Okay, what we want to do is bring down another 0 and keep on going. Now, if you find it keeps on going forever, let's maybe check our work and see what we've got going on there. Or maybe it's asking us to round the problem to the nearest something, because there are numbers that can go on forever, but most numbers are going to kind of end after a certain point.